Bitcoin and other applications of blockchain, Chunk24, Professor Massimiliano Sala, University of Trento. Storj, a decentralized cloud. In this chunk, we will introduce a decentralized cloud. One example is Storj, a peer-to-peer cloud storage implementing end-to-end encryption that allows users to transfer and share data without reliance on a third-party data provider. We will describe how Storj works, its proof of storage method, and how it uses blockchain technology. The definition of cloud computing given by NIST in Special Publication 800-145 reads as follows. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Now, what is elasticity? Well, the user has guaranteed access to a multitude of different platforms via the network and can run applications without having to worry about hardware. Moreover, the computational resources are released in a flexible manner on demand. Low cost. There is a decrease of cost because the management of the files, software and hardware is in the hands of the cloud service provider. Reliability. A cloud network is managed by a group of people certainly more competent than the average user. So these are the pros for a cloud system. Now what about the cons? We read the sentence by Richard Stallman, the founder of the Free Software Foundation. One reason you should not use web applications to do your computing is that you lose control. Indeed, we have latency, violation of privacy, and security issues. The latency, the time required to synchronize data, can offset the benefits of the enormous computational power. Privacy, we have huge potential problems of violation of your privacy. And security, are we really sure how the cloud network manager managing your data? Anyway, if we have a decentralized cloud, the things are different here. There is no central authority managing the service, and instead we have network users that share two things: storage space on their computer and the internet connection. The example we look at is Storj. Storj stores and transmits data in a secure way using end-to-end encryption. Storj uses a decentralized network and uses blockchain, but not the Bitcoin blockchain, as we will see later. Storj uses public and symmetric cryptography and hash function, and it's definitely cheaper than traditional cloud service. Storj, how it works? Well, each file is reduced to small fragments called shards. Each shard is encrypted with a symmetric key of the creator of the file. Then, the encrypted shards are distributed among the participant nodes, and these nodes are called the keepers because they keep the shards. And finally, the information of integrity and of the network position of the shards are all inserted into the blockchain, which is necessary to reconstruct the file. The keepers are regularly challenged to show that they do have the shards they've been assigned and they didn't dump them. Through challenges based on the calculation of certain values of hash function, the keepers can prove mathematically to have kept the shards without having tampered with them. The traditional cloud storage uses different data centers to protect the data of users from physical damage. In a decentralized cloud, the files are stored in a decentralized network. Therefore, they cannot be entrusted to a single keeper. In particular, Storj implements a data encoding scheme which ensures that the file is divided into n shards and is completely retrievable whenever you put together just k of these n shards. In fact, the scheme is called k of n erasure encoding scheme. The creator of the file chooses parameters k and n based on the importance and sensibility of the stored data. There are, of course, some default configurations, like n equal 3, n equal 4, and generally k is 2. But if you have sensitive data, then you can use also 500 as n. What about security? Well, here the blockchain comes in. The blockchain here acts as a repository of information. No user data is stored in the blockchain, but all information necessary to verify keepers, for example, the hash values of the shards, and the net location of the shards. Storj uses the blockchain of Florin coin. We read this sentence from Sean Wilkinson. It's easy to steal a cookie from a cookie jar in a secluded area, but it is hard to do so when the jar is instead located in the middle of a public square, being observed by thousands of people. To encourage a correct working on the network, honest keepers are rewarded. Whenever any keeper proves to have kept a file, he will receive a micropayment in a cryptocurrency called Storj coin X. In traditional cloud services, the storage management and distribution of user files is provided by the servers, which are always accessible. Whenever a user wants to store or request one of their own files, the server provides the service. But here we have a traditional peer-to-peer network. So the storage, management, and distribution of user files is provided by the peers. And we don't have much control on the peers. So in this case, one of the problems may be the insufficient number of peers, which can slow down the transfer of files. As a consequence, a small number of keepers can make the transfer of files difficult or even impossible. There is a solution to that. Storj copes with this problem by paying the keepers that own popular shards with Storj coin X. So the users are encouraged to become keepers of the most popular shards, which are the shards which are more requested and they require more internet connection, increasing thus the efficiency of the system. However, we observe that now Storj is being released as a beta version. So we'll see if it will actually work. We can summarize what we have learned so far. We have introduced decentralized cloud, describing its pros and cons. In particular, we have given an example of the peer-to-peer cloud storage network, Storj. Storj works in the following way. Each file is reduced to shards. The shards are distributed among the keepers. The keepers are regularly challenged to show that they have the shard they've been assigned. Information on the shards is inserted into a blockchain, and the honest keepers are rewarded with a micropayment in Storj Connects.